Sorry, we...
Hello, Vladimir. Доброе утро. Доброе утро, my friend. I can't see you, but I listen your voice.
Thank you very much. We also can hear you. So you can start the presentation.
Yes, very nice to be with you again, even only virtually. And I'm very happy to connect for your birthday. And I wish you all the best for your upcoming years. And I'm happy also to introduce my fellow from IRCAD Strasbourg, that is Dr. Yuchuan Chang, that is from China, but he became a doctor in Russia. So he is a very special person because he is a Chinese origin. Yuchuan, good morning. You can activate your microphone, Yuchuan.
Yeah, sorry for that. Good morning, everyone. И всем здравствуйте.
Здравствуйте.
It's fantastic. I love Yuchuan because this way I can be in contact with Russia. And he helped me in the preparation of this talk that you are going to make. And we are going to discuss about what's new in the stapling technology. So let's see more than stapling in the anastomosis. So I will show you the presentation and the diaporama from the beginning. So I thank a lot Yuchuan for this presentation. And Yuchuan is very special because he's born in China, in Shanghai. He studied in Russia. Which city of Russia, Yuchuan, did you study?
Well, first I studied in Volgograd, and then I worked in Volgograd and in Moscow also.
Okay, excellent. Then he got married with the Russian lady, so he's very much attached to Russia. And now he's working in Strasbourg, at IRCAD Strasbourg, together with me, and he's going to do a lot of good things. I'm pretty sure of that. So Vladimir asked me to talk about what's new in the formation of anastomosis. And I think that first of all, to start the presentation, we have to recall that anastomosis, as we know, is the basis, is the foundation of digestive surgery. So without a good anastomosis, we can do excellent dissection, excellent oncologic procedure, but we do not achieve the restoration of bowel continuity. So for the patient, this is not good. But unfortunately, sometimes our anastomosis don't work. So we are still looking for the best solution to solve the problem of anastomotic leak. Please, Vladimir, tell me if I speak too fast, and if you need any explanation, Yuchuan can translate in Russian. I can stop after each slide, and Yuchuan can translate in Russian. What do you think?
I think everything is correct. I think the auditory... Antonello, everything is okay. You can speak as you speak now.
Okay, fantastic. So I will go ahead. So there is a problem of anastomotic leak.
Antonello, sorry, it's Alexey Karachun speaking. If you know 7 languages, why don't we understand English?
Okay, you know 7 languages?
No, you know. As I remember, you told me.
I don't know 7. I just speak a couple of them. But,
believe me, you know.
I would have loved to learn Russia when I was coming to visit you so many times. But now with Yuchuan, I think I'm going to learn again. You know, in Milan, I had also a Russian assistant, Tatiana. So Russia, it's in my heart, very much in my heart. And it will always be there. Thanks to Vladimir, especially. So let's go back. So I think all around the world, we all know that stapling comes from Russia. So it was developed to solve the issue of allowing Russian surgeons in remote areas to guarantee a good surgery, even if they were not especially skilled. So the story of stapling comes from Russia, Then the Americans made the business out of it, but the idea of the stapling comes from Russia, and I always acknowledge this in all my talk. Nowadays, there are some advancements, and we must be aware. First of all, the first advancement is that today the stapling, they are motorized. They are called the robotic stapling, but actually they are not robotic. They are electromechanical activated. They have some sort of intelligence because this stapling can sense the tension, the thickness of the tissue, and can adapt the speed of the closure of the cartridge according to the thickness of the tissue. So by this way, the staple line, it's more regular, it's more effective, at least in terms of the closure. This is from Medtronic, at that I'm sure that you all know very well, and this stapling, it's called the Signa. So the cartridge are the regular one, but the activation is electromechanical and motorized. Now, this stapling is going to be included in the new robot that comes from Medtronic that is called the Hugo robot. So we are going to see this technology implemented into the robotic system from Medtronic. What I think it's very interesting is this stapling that we found with the Yuchuan. That is a 5mm stapler coming from an Israeli company, even though now it's bought from a US company. And this is very interesting, not because it's a 5mm, but because it allows to have a more precise positioning, especially, for example, in the chest. In the chest, when we want to do esophagectomy, for example, I saw the previous video, it's very interesting because it's smaller and you can position even in small areas of the body. The other very important evolution of the stapling technology is the level of articulation of the stapler. As you know, all the stapler that we have today can achieve an angle that is a maximum 45 to 60 degrees. But this company from China, RichMed, has developed a stapler that is electromechanical and that has a 90-degree articulation of the cartridge. So this, especially in the deep pelvis or up into the chest, when you deal with the esophagus, I'm pretty sure this will be very, very successful. I've never tested it in person, but I believe that is going to work very well, as nowadays all the tools that come from China are of a very high quality. But this is, let's say, this is somehow older technology, or it's let's say, evolution of a standard technology. What we propose today is a new idea of performing anastomosis, and is based on the use of magnets. So what we can do, we can deliver a piece of a magnet inside a closed lumen, like it could be the esophagus, and we can put another magnet into the bowel, and the two magnets, they come together and they create an anastomosis by compression. So it's not immediate anastomosis, it's an anastomosis that comes out of compression. This mechanism of anastomosis is going to gain, in my opinion, a lot of interest, and if the clinical data will confirm what it appears to be very effective, we are going to see more of this anastomosis in the next future. So the idea is that with an endoscope, we push down through the endoscope a small magnet that will become like a circular stapler inside the lumen. On the opposite side, we put another magnet, and the two together, by compression, they will create the anastomosis. With the same principle of using the magnets, today we can deal also with biliodigestive anastomosis, that, as you know, are more delicate, and especially they are related to more leakage, more stenosis, and so on. So also this type of anastomosis will benefit of this new technology. All these will allow to facilitate the performing of the anastomosis, even when the patient has a difficult structure or some problems. As we know, the biliodigestive anastomosis, they must be performed with very, very small stitches. So this is a very interesting review that Yuchuan has found from South Korea that show the promising results of using magnets to perform biliodigestive anastomosis. So we are going to see this more and more in the future. Another interesting innovation in the field of mechanical anastomosis is related to the use of a nitinol ring instead of little agraff to create the anastomosis. So this is a stapling called the Niticar that comes from Israeli company. And here again, the idea is to create the anastomosis between the colon and the rectum by using a compression nitinol ring. So you do not have the typical triple line of a graph of the actual stapling, but you have 2 rings of nitinol that will stay connected together, and by compression, they will develop the anastomosis. The results, as you see, in terms of efficacy between the nitinol anastomosis and the control anastomosis are very much comparable. The advantage is that we can customize better this ring instead of the stapling, because the stapling technology using the agraff has some, let's say, physical limitation. With the nitinol ring or with the nitinol stapling system, we can achieve a different type of staple in different places of the body. Then one further evolution of the anastomosis with the goal to have less complication is represented by this intraluminal bypass device. So what is the goal of this system? The goal of this system is that when you have performed the anastomosis, you want to preserve the anastomosis from the leakage. So in case, for example, you have a little disruption of the anastomosis, if you have this sort of intraluminal bypass, what happens is that the little disruption of the anastomosis will not determine a clinical leak. So you still have a disruption, but you don't have all the complication, all the clinical complication of the leak. So this is very promising. In Strasbourg at IRCAD, the local team, the colorectal local team, has tested this technology with very positive results. So here the goal is to improve the colonic, the bowel anastomosis, not by improving the stapling or by improving the mechanism of the anastomosis, but by protecting the anastomosis. And this is the reason why we shared this information with you. The other important thing is related to new biomaterials that are coming in the market that are going to cover the anastomosis in order to reinforce the natural healing of the tissue. So we know that all the stapler, all the magnets, all the nitinol ring, they're going to do a mechanical anastomosis. But what has to happen is the biological reaction. Now, we know that the biological reaction depends a lot from the condition of the patient. If the patient is old, if the patient has a vascular problem, is diabetic, has cortisone, and so on. So it's not a mechanical, anastomosis is not only a mechanical problem, it's a biological problem. So Yuchuan found a lot of articles about new materials and new sealants that can reinforce the anastomosis, like smart hydrogels, tissue adhesives, and they seem to really improve the quality of our anastomosis. So there is nothing at this moment that is, or at least in best of my knowledge, there is nothing at this moment that we can say this is commercially available, but I'm pretty sure that in the next future, we will see more and more of this material. And the other important news is that most probably in the future, the anastomosis will be done by the robot. So this is an experimental setup coming from a team in Boston, where they have used artificial intelligence, augmented imaging, and a robot to perform an automatic bowel-to-bowel anastomosis. So I'm pretty sure that as we see in the streets cars going by themselves, we will see at a certain moment in the OR some anastomosis that will perform automatically by the robot. It's not for all type of anastomosis, but some of the anastomosis will be done by the robot under the supervision of the humans. As you know, the robot has a level of precision and of perfection that we cannot achieve by ourselves. Of course, the quality of the mechanical junction, it's only one of the elements, and for this reason, Yuchuan associated the value of the robot with the value of hyperspectral imaging in order to assess the good vascularization of the tissue. If you don't have a good vascularization, even if you have the perfect robot, the anastomosis is not going to work. In the same line, if you will, in the same philosophy, there is also the role of artificial intelligence to automatically understand which is the level where we have to transect the bowel in order to have a good edge of bowel to anastomose with the other side. So this is again an experience that has been developed in Strasbourg at IRCAD with the team of Michele Diana and Antonio D'Urso, two Italian researchers that were working at IRCAD till some years ago. And what they tested is an automatic software that will tell the surgeon exactly where to cut. All this is done automatically by the machine. So it's not anymore the surgeon that will judge if the quality of the vascularization is good, but it's artificial intelligence that will tell you if it is good. Finally, we are going to see maybe new device like this one that in just one shot will do a perfect end-to-end vascular anastomosis. Look at this. It's very, very, very nice. This is very nice. It's like two buttons that close together. And these are new ideas that most probably will come and will allow us to do even more advanced cases. So we spoke about the reinforcement. The reinforcement is also for the pancreatic anastomosis, and we also have to remember that we have also anastomosis of the urinary tract that can be, let's say, improved by using fluorescence imaging or robotic assistance. So to conclude, what we have to tell you is that the story of stapling started in Russia. Today, we have understood that the quality of an anastomosis is much more than just the mechanical junction. So we must absolutely understand which are the issues related to vascularization, tension, type of tissue. We have to use new materials, new chemicals to reinforce the nature of the patient in order to perfect the anastomosis. And we are pretty sure that the new technologies, including the robot, will improve the quality of what we can do today. So thank you very much, and I hope that this was informative for you, and I'm happy to receive all your questions.
Thank you very much, Antonello. Excellent presentation.
My pleasure, Barad.
Thank you very much. Maybe Alexei, your friend.
Well, thank you very much, Antonello, for the excellent presentation. Sorry for my English, but
perfect. Like your surgery and your English are perfect.
Oh, thank you. Antonello was the first foreigner surgeon who was invited to our clinic, and we performed several colorectal resections together. And thank you very much. I will tell you, everyone, thank you very much for the whole time. But
thank you to you for the invitation. It was my pleasure, and it's deep in my heart what we have done together.
Thank you. And I'm happy to have a contract with French company Calavac. And tomorrow, I think, the American Society of Colorectal Surgeons will held in San Diego in the United States, and Patrizia Celia will talk about our experience in Colovac system. I have a contract, and I performed 25 surgeries using Colovac, and we have a very good data. And I was happy to have this device, and I believe that international multi-center trial that started in French, maybe 7 European countries and the United States. After that, we will have this device. It's very good experience. And I have only feelings, but these new devices come to us very fast. They are very close to us, and I'm happy for that. And thank you very much for your information about several new ones. But my question is, what about your robot?
I hope,
Nice question.
I hope it will be I hope it will be ready very soon, but we are not yet there. We are now going towards the certification for the first part of the robot, that is automatic camera robot that should be available starting from the beginning of next year. So I will be happy to have during one of your next workshop a presentation about that. It was not supposed to be the topic today, but I hope that by beginning of next year we can start to use the first robot of the Milano robotic platform. That is the one I invented and Vladimir knows many years ago. It's a very long run, my friend. It's a very long run, and technology is complicated, and all the certification process, if you are not a big company like Intuitive or like Medtronic, if you are a small company, it's very complicated. But we are getting close to it. It will be a pleasure to test it together with you.
Thank you very much, and please take care using your bicycle. Okay.
My motorbike.
Okay,
My motorbike now, unfortunately, it's in the garage because I have a very limited time. You know, now I work in Strasbourg 90% of my time, and I am the general director of IRCAD since 2 years now, and the work there, it's very much. And I'm happy that I have a nice fellow like Yuchuan to help me to prepare. And we work together a lot also in the lab. We are doing a very nice experience, and I wish I can see you again coming to Strasbourg very soon.
Okay, thank you very much, because I thought a lot about your motorbike experience, because I was ski in Chervinia 2 months ago and have damaged my shoulder, and I've been operated 1 month ago. So I decided to maybe I will not buy a bicycle at least. Thank you very much. Take care.
Thank you to you. Thank you to you, and we stay in touch. And I'm sure that we are going to do again a very nice thing together.
Dear Antonello, hi. This is Elena. I am just the
Elena,
chief.
good morning. Dobro utro.
I am just the chief of this clinic, and I'm very happy to greet you. And I'm very sad that you are not with us. Do you see us or not? Only here?
No, unfortunately, I cannot see you. I can see only me speaking and Egor Pavikov, but I can see my picture also in Egor window.
In spite of it, I'm very happy that you are with us, and the excellent lecture, and welcome to Russia once again. Thank you very much.
Very soon,
Thank you,
very soon
Antonello.
I will come back with great pleasure, and to meet my very good friend Vladimir, that we know each other now for more than 20 years.
Antonello, thank you very much. Hope I can see you soon.
We will, for sure.
Of course, my friend. I shall do all my
We
best.
know that you are an Italian member.
Thank you. Какие вопросы? Коллеги, есть? Antonello, thank you very much. Have a nice day. You know, you are very busy, so thank you that you find time to be with us.
And please thank Yuchuan for his very important contribution. Please.
Yes, it was, he's a very nice guy. All the best to him also.